Hello everyone. Today we'll continue with your next numerical for moment distribution method. Okay, the change in this numerical is what? Loading is changed and here you are having a overhanging portion over there on your left side of beam. Okay, if you see over here a continuous beam A, B, C, D, E is given to you. Okay, in which from B to point E a constant UDL of 3 kN per meter is given to you, and between this overhanging portion, that is AB, a UDL of 2 kN per meter is acting over there, and along with that a point load of 8 kN is acting at the center of the CD member. I have marked that point as F over there. Length of AB is 2, BC is 5, CD is 5 and DE is again 5 meter over there, and additional one thing is given to you, that is EI is constant for all these members over there. So I values will remain unchanged over there for all the members. Okay, so we'll start with the solution for this. The first initial step is what? You have to calculate the value of dk. Okay, so dk here it will be how much? Theta b, theta c and theta d, while as theta e will be your basic known value, so it will come equal to 0. So total dk I am getting here equal to 3, that is theta b, theta c and theta d over there. So this will be my unknowns over there, and my basic known value is what? That is theta e will remain 0. Okay, then we'll move to second step, that is your fixed end moments over there. Okay, now in this overhanging portion you are having joint B, C, D and E. A will be not treated as a joint, remember. Okay, A will be not treated as a joint over there. So friction moment will be calculated from support to supports over there. So first friction moment, that will be our MF BC. What is given to you? Loading UDL is given to, so that comes equal to minus WL square divided by 12, so that comes equal to minus 6.25, that is 3 into 5 square divided by 12. Okay, all these values are in kilonewton meter over there. Same way MF CB, same value, just magnitude will get, sign will get changed, that is plus 6.25. Next MF CD. Now in MF CD there are two loadings given, UDL is also given to and point load is also given to. So for UDL you will get as minus WL square divided by 12 minus WL divided by 8, that will be for point load. So this will be for UDL and this will be for point load over there. So whatever W value here, it will be of UDL, that is 3, and here W will be equal to 8 over there. So if you simplify accordingly, you will get this value equal to minus 11.25 kilonewton meter. Okay, same way MF DC, it will come equal to plus WL square by 12 plus WL by 8, because restoring moments will be clockwise here, so you will get that as plus 11.25 kilonewton meter. And the last portion, that is MF DE, again loading UDL is given to throughout the span, so MF DE will be again WL square divided by 12, so it comes equal to minus 6.25 kilonewton meter, and last will be your MF ED, so that comes equal to plus WL square divided by 12, it comes equal to plus 6.25 kilonewton meter. So this will be all friction moments that will be calculating over here. Okay, in addition to this friction moments, what will happen? You are having a overhanging portion AB over here. So this overhanging portion will introduce some moment on this joint B over there. Okay, so that will be your additional moment for this AB. So here I'll calculate that additional moment coming at joint B, I'll call that as MBA over there. Okay, that will be how much? So additional moment, it comes equal to 2 UDL acting length, intensity of UDL multiplied by its acting length multiplied by its lever arm. So lever arm will be at the half of this 2, so that moment comes equal to intensity of UDL 2 multiplied by its acting length is 2, and lever arm will be half of your acting length, that is 2 by 2, and that moment restoring sign, this will introduce a moment of anti-clockwise nature on B. Its restoring moment will be clockwise in nature, so that comes here positive. Okay, so this comes equal to 2 into 2 into 1, that comes here equal to plus 4 kilonewton meter. That will be your additional moment for BA over there. Okay, then next step number 3, you have to calculate the distribution factors over here. Okay, for distribution factors we have seen the table over there. In table, your first column is what? Is your joint. Second column is your members meeting those joint. Next is relative stiffness K. Next is total stiffness summation of K, and last is DF is equal to K divided by summation of K over there. Okay, now in first column, while considering the member joints over there, okay, I have told you in the previous lecture that you have to consider only those joints over here which are having 2 or more than 2 members. Okay, for single jointed member, your distribution factor will remain always equal to 1. Okay, so you have to search such joints over there in your numerical. At B, this will be not treated as a member because this is overhanging part over there. So B is treated as a joint which is having only 1 member over there. Okay, next joint is your C. So C is having 2 members. So first joint here I am writing as C. Okay, members meeting joints here C, B. Sorry, first is your CB and second is your CD. Okay, this will be my first joint. Then next we will see for D joint. Again it is having 2 members. So D joint will be considered over. Members meeting D joint are DC and DE. Okay, now last member E will see, it is having only 1 joint, so no need of considering that in this table over there. So that will be remaining as it is, or its distribution factor will remain 1 over there. Okay, now relative stiffness, here near end will be C, far end will be your B over there. Okay, so B you have to check over there. So B is what? This type of support is what? This is your end support over here. Okay, which is not continuous further. So this type of support is called as your incapable support. Okay, this will be your capable one. This is also the capable support because these two are the intermediate supports over there, and the last is fixed support. Fixed support is always considered as capable support over there. Okay, so B is your incapable support. So for incapable support, relative stiffness comes equal to 3/4 of I divided by L of CB is your 5. So that comes here equal to 3/5 into 4, 20. If you calculate this 3/4, you will get as 0.15 of I over there. Okay, then next is your CD. Now you check for D joint over there. D is what here? Capable support area. So for capable support, your relative stiffness comes equal to I by L. L of what? CD. L of CD is given to equal to 2.5 plus 2.5. That comes again equal to 5. So I by 5 will come equal to 0.2 of I. Okay. Next, then total stiffness. Total stiffness is what? Summation of all the relative stiffness meeting at a joint of all the members over there. So 0.15 plus 0.2, I'll get this as equal to 0.35 of I. In last column, distribution factor for member CB. It is what? K divided by summation of K. That is 0.15 I divided by 0.35 I will get cancelled. Here comes equal to 0.43. Okay. Same way, 0.2 I divided by 0.35 I will be distribution factor for CD. That comes equal to 0.57. Check whether this addition of these two values is coming 1 or not. 0.43, 0.57, it is coming equal to 1. Okay. Now, for D joint over there, members meeting joint here D, D, C and DE over there. Okay. So here C is your far end over there. Moment is transferring from D to C. Okay. So check C joint. C is again capable over here. So relative stiffness will be again equal to I by L. L of DC is your 5. So that comes equal to I by 5 will be equal to 0.2 of I. Next, DE. E will be your far end, that is considered as capable joint here. So again relative stiffness will be here equal to I by L. L of DE is again equal to 5. So that comes equal to I by 5 equal to 0.2 of I. If you add this comes equal to 0.2 plus 0.2, it will be 0.4 of I. Then df for dc, I k upon summation of k, that is 0.2 I divided by 0.4 I get equal to 0.5, and here also I will get equal to 0.5. Summation of these two will be equal to 1, and summation of these two shall come equal to 1 again. Okay, so these will be my distribution factors for members, joints having more members over there, 2 or more than 2 members. Okay, now next step will be your moment distribution table over there. Okay, I have told you in the last lecture, your first 4 rows will remain common, that is first row will be your joint, second will be your members meeting this joint. Okay, the third row, that will be your distribution factors, and the fourth row will be your calculated fixed end moments over there. Now joints over here, joints you have to consider all the joints given in your complete beam over there, that is first joint will be your B, second C, D and E. So I am marking here all the joints. First is joint is my B, second is your C, D and last joint is your E over here. Okay. Next in this, what you have to do is you have to consider the members meeting these joints over there. Okay, so members meeting joint B are which one? You are having member first B, C over there. Okay, but here B also you are having overhanging portion over there. Okay, this will not be treated as a member over there, but we have additional moment of 4 kilonewton meter over this. So we have to consider this moment in this table over there. So here I am writing that as BA over here. Okay, next is your joint C. C is meeting joint CB and CD. Next joint D is meeting DC and DE, and last is your joint E, it is meeting member ED over there. Okay, so this will be my all the members which I will consider over there. Now next what I have to do, I have to write the distribution factors over there which I have calculated. Okay, for CB it is equal to 0.43, next for CD it is 0.57, and for DC and DE both it is equal to 1, and for remaining ED and BC it will remain equal to 1 over there. Okay, next fixed end moments I have calculated that is for BC I have got minus 6.25. Okay, next for CB I have got plus 6.25. here for CD I am getting minus 11.25, for DC I am getting plus 11.25, DE I am getting minus 6.25, and for ED I am getting as plus 6.25. In addition to this I am having an additional moment of 4 kilonewton meter, that is positive 4 for BA member over there. Okay, so this will be my first 4 basic rows in this moment distribution table. Now after these 4 rows, what you have to check is that you have to check whether you are having 0 moment at your incapable support or not. If no, you have to balance that moment over there. Okay, so check the incapable support. Incapable support is your B over here. Okay, but at B you are having minus 6.25, and in addition to that this 4 kilonewton meter moment over there. So what you have to do, you have to balance the remaining moment from this over there. Okay, that means what are these 4 kilonewton meter moment which is acting at this BA member, it will remain constant throughout the numerical because this overhanging portion will remain as it is. Okay, that means this 4 whatever moment you are getting over here, that will remain constant throughout this throughout the lifetime of this beam over there. That means you cannot remove this AB over there, that is this AB will put always a moment of 4 kilonewton meter on this joint over there. So this moment will remain constant over there as it is. Okay, so what will get changed? Minus 6.25, but if you make this moment 0, that is plus 6.25, your this moment will get changed over there. What is the thing? Your this 4 must also remain constant, and your this moment must also become 0. So what will be my balance moment? That will be equal to 4 minus 6.25, that is total magnitude of this I will get as minus 2.25. Okay, so that 2.25 I have to make it as 0. So I will write here balance moment of plus 2.25. Okay, I'll repeat again. This is 4 and minus 6.25. This 4 will remain constant throughout its lifespan of beam, because that overhanging portion will introduce always a 4 kilonewton meter moment over here. Okay, so what is this additional moment I am getting? Plus 4 minus 6.25, that is I am getting summation of this as minus 2.25. Okay, summation of these two moments I am getting as minus 2.25 over here. Okay, so what I have to do? I have to nullify this as my balance moment over there. Okay, so I have to nullify this. So what I'll do? I'll apply opposite moment for this, that is plus 2.25 as my balance moment over here. Okay, now after applying this balance moment, what comes further is your carryover. Carryover is what? That is whatever balance moment you are applying here, half of the moment will get carried out to its next capable support over there. So if you check here, C from BC moment will get carried out to CB over there, that is moment from B will get carried out to next joint C over there, that is, but condition is what? Whether C is capable or not. Okay, it is capable over there, so this carryover is possible. So carryover is what? Half of the moment will get carried out to this, that is plus half of this is 1.125 will get carried over to this. So I'll get here my initial moments over there. Okay, initial moments, this 4 remains as it is. Okay, next minus 6.25 plus 2.25, this becomes as minus 4. Okay, next 6.25 plus 1.125 I will get as plus 7.375, this will remain as it is, minus 11.25, this will remain as it is, plus 11.25 minus 6.25, and here again plus 6.25 over there. Okay, only you have to apply a balance moment at your incapable support. Here your B support was incapable over here, that is why we are applying balance moment over here. If in addition to this, suppose E support is also incapable given, suppose this will be a hinge support over there, so what you have to do? You have to apply balance moment here also and at joint E also. Getting? Sorry. So I am getting my initial moments now. Now what I have to do? I have to distribute these moments according to this distribution factors I have calculated over here. Okay, now see properly how to distribute the moments. After initial moments, the next part, that will be your distribution. That will be the distribution over here. Now distribution of which moments you have to do? For which you have calculated the distribution factors over there. Now while distributing these moments, you have to distribute this according to these distribution factors, that is, you have to add the moments at this joints over there, for which you have calculated the distribution factors, that is plus 7.375 minus 11.25. What are this factor you will get? Plus 7.375 minus 11.25 multiplied by distribution factor for CB will be your distributed moment for CB, and again this magnitude multiplied by your distribution factor for CD, that is 0.57, multiplied to this you will get your distributed moment for this CD over there. If you check, you get this moment as 7.375 minus 11.25 as minus 3.875. You will get that as minus 3.875. So minus 3.875 multiplied by 0.43, you will get that equal to 1.166. 1.666 you are getting. Okay, you can write 2 decimals or up to 3 decimals over here. Okay, but you are getting this negative over there. Again 7.375 into 11.25, how much I am getting this? That is 3.875 multiplied by your distribution factor 0.57, I am getting this as 2.20 over there. Okay, but whatever this magnitude you are getting, that is coming negative over there. Always remember one thing, you can write in your margin over there upward side, while distributing the moments over here, distribute those moments with the opposite sign whatever you are getting. That means this magnitude whatever you are getting plus 7.375 minus 11.25, this is your negative, so distribute it with opposite sign, so its opposite nature will remain positive. Okay, that is because you have to balance that moment further. Next, now we will distribute these moments over there, that is plus 11.25 minus 6.25, that is I am getting 11.25 minus 6.25, I get that as 5 over there. Okay, 5 multiplied by 0.5 and 5 multiplied by 0.5 will be distribution for DC and TE, that is 5 into 0.5 I will get as 2.5 and 2.5. Now if you check here, whatever magnitude I am getting that as positive, distribute with opposite sign, so here distribution will be done as negative over there. Getting? Then after distribution you have to do is carry over there. Now while doing carry over, which moments you have to carry over? Which moments are carry over to your capable supports over there. Okay. Now check whether your CB moment is getting carried over to BC or not. Okay. Now if you check B over there, B is your incapable support over here, so it will not take moment from C support over there. Okay. So this carry over will not be possible over here. Okay. Then now we will check whether your moment from CD will get carried over to DC or not. Condition is what? Your D must be capable of taking that moment over there. Check whether D is capable. Yes, it is capable. So this carryover is possible. Same way you check whether your DC can do a carryover moment to CD or not. Condition must be what? Your C must be capable now. Check whether your C is capable. Okay, it is capable. So this carryover is also possible here. Next, we will check for this moment over there. Now TE moment will get carried to ED over there. Okay. Check whether your E support is capable. Yes, it is capable. So this carryover will be also possible over there. But carryover shall be how much? It is equal to 1/2 of the applied moment over there. Okay. So carryover, that will be how much? Plus 1.10, half of this, half of 2.5, that will become minus 1.125. Okay. And here again I will get that, sorry, this will be 1.25, correct this, half of 2.5 will be 1.25, and here I will get again minus 1.25 over there. Always remember, distribution, while you are doing distribution, distribute the moments with opposite sign, and while applying carryover, do the carryover with the same sign of the moment. If it is positive, do the positive carryover. If it is negative, do the negative carryover there. Okay. So this will be your obtained moment now for joint C, and this will be your obtained moment now for joint D over there after doing the carryovers over there. Now you have to repeat this cycle again, that is distribution, carryover. Again what you have to do is the distribution. Okay. Now distribution of what? Here you are having 0 moment over there. Okay. 0 minus 1.25, that you will get as minus 1.25. Okay. Minus 1.25 into 0.43 and into 0.57. So I get this as 0.537 and this I get as 0.712 over there. Now this summation is negative over there. So distribute you have to do with opposite sign, so that will remain as positive. Okay. Same way here you are having 0. So 1.1 and this 0 summation will be plus 1.1 into 0.5 and 0.5. So this distribution will be now negative in nature. So that comes equal to 0.55 and again 0.55 over there. Getting this? After this you have to do is what? Again the carryover moment. Same cycle you have to repeat. Okay. Carryover factor is your 1/2. So apply a carryover factor of 1/2 for these moments over there. Okay. So 0.55 divided by 2, I get that as minus 0.276. Okay. Same way 0.712 divided by 2, I get that as plus 0.356. Next way 0.55 divided by 2, I get that again minus 0.27 of 6, and the last again you have to do the distribution. At least you have to repeat the 2 to 3 cycles in this moment distribution table over there, or you have to repeat the cycles up to the conditions who is what? You are getting these values in 0 point or not. Okay, 0 point, if you are getting these values, you leave the table. Okay, but where you have to leave the table? After doing the distribution. Always remember, this will be your one more concept, whether when you have to leave the table after doing the distribution table. Okay, after doing the distribution of the moments over there, do not leave the table after doing the carryover. If your table is ending at the carryover, then it is okay, but if your cycles are repeating again and again, so end that table after doing the distribution over there. Okay, so we'll distribute again this minus 0.276 to the distribution factors over there. So this is your negative, distribution will be done as positive again. Okay, I am not having more space over here, so you see properly. 0.276 will be distributed for 0.43 and 0.57. So 0.276 into 0.43 and 0.5357, I'll get that as 0.118, and this I am getting as 0.157. Same way, 0.356 I'll distribute for 0.5, 0.5. This is positive in nature, so distribution will be negative over here. I'll get that as 0.178 and again 0.178. Now all the values, if you see, I am getting almost in 0.1 something points over there. So we'll stop the table over here and we'll be calculating the final moments over here directly. Okay, now final moments, this 4 will remain as it is. Okay, next this minus 4, that will remain as it is because these carryovers were not possible over there. Okay, now final moment for CB joint. CB joint will be how much? That will be your addition of all the moments from your initial moments over there. That is plus 7.375, 1.666, 0.537 and 0.118. I will get that as plus 9.69. Your decimals may get vary over there here. Okay. Next for CD, again add these values. I get that as minus 9.69. Same way, this I am getting as plus 9.48. This I get as minus 9.48, and this I am getting as plus 4.724 over there. Okay. Now if you check your conditions of equilibrium over there that we are solving in slope deflection method. See, if you see over there, condition of equilibrium will be what? MBC shall be equal to this overhanging moment over there that I am getting over here. Okay. Next, at this joint C, what will be my condition of equilibrium? MCB plus CD shall come equal to 0. Check. MCB and CD you are getting 0. Yes, I am getting 0. Next, at D, MDC and MDE shall get 0. Check whether here. Yes, here also I am getting 0. That means your conditions of equilibrium are getting satisfied. Here your decimals may vary somewhat over there, 0.01 up to 0.05 values it may vary. Okay, that is acceptable. But how many cycles you repeat over here, that gives you more perfection for these values over there. Okay, so this obtained moment I am getting as my final moments over there. Okay, so what I'll do, I'll write my moments over here. Okay, here I'll write here, that is just step number 5, final moments over there. Okay, MBC, MCB, MCD, MDC, MDE, and last is your MED. Okay, BC I am getting as minus 4 plus 9.69 minus 9.69 plus 9.48 minus 9.48 and plus 4.724 over there. Okay, so these I am getting as my final moments. What I'll do, I'll plot my BMD by superposition over there. Okay, A, B, C, D, and here I am having E over there. Okay, from BC we will start because this is our overhanging portion over there. So for BC, sign convention is what again? Negative, positive, positive and negative over there. Check MBC, how much you are getting? Minus 4 I am getting, so that will be plotted on upward side 4. Okay, then MCB, that I am getting as plus 9 point something. Okay, next CD, I am getting minus 9.69, already it is plotted. MDC plus 9.48, so smaller from this somewhat, 9.48. Now MDE, okay, minus 9.48, already it is done, and last is MED, 4.724 positive, so greater than this 4 it will be 4.724 4. Okay, and what you have to do is you have to just join these lines by a straight line over there, and what will happen here for overhanging portion, that will remain equal to 0 over there. Okay, this will be my support moments. After that, what I have to do, I have to calculate the maximum span moment over there. Maximum span moments for BC, CD and D over there. For BCD I am having 2 over there, that is first is for UDL and second is for point load over there. Okay, so this will be WL square divided by 8, again WL square divided by 8, WL by 4 and WL square divided by 8 over there. If you check these values, you will get WL square by 8 as 9.38, same here 9.38, same here 9.38, because why? Your UDL is not getting changed and your length of all these members BC, CD and D are constant, that is 5 meters. Okay, just here point load will get changed, that is point load is how much? It is given to equal to 8. Okay, 8 into 5 divided by 4, I get that as 10 over there. Okay, so I will plot these moments over there. In portion BC you are having UDL, so it will follow parabolic path 9.38, somewhere here it will be okay, WL square by 8, that is 9.38. same way it will be in this portion also, and it will remain in this portion also 9.38, and here also I am having 9.38 over there. Okay, next what is remaining? Just this point load is remaining. It will follow a triangular path which is having a moment of 10 over there. WL by 4, it is equal to 10. Okay, and just what you have to do? You have to do is what is the shade your superimposed part over here. So this will be my final BMD by superposition. Okay, numerical was somewhat tricky over there because overhanging part was included in this. Along with that, loading was also complex in this, so that made the numerical difficult, but I hope you have understood it very easily. Okay, if you are having any doubt, any questions about this numerical, you can comment in the comment box without any hesitation. Okay, thank you so much.